Hi guys, this is Mrs. Tran-Bloom recording for our very first example in 7.3. So the title for 7.3 is trigonometric equations, okay? So now equation means an equal sign is involved. So solve on each interval, and for this one, the interval is from 0 to 2 pi inclusive. So what we're going to do is we are going to find all of the answers for theta in between 0 and 2 pi. So you're going to solve this normally. We are going to add 1 to both sides. So we will have 2 cosine 2 theta equals 1. Divide both sides by 2. Okay. Then we will have cosine of 2 theta equals 1/2. Then what we will do is we're going to say, hey, you know what? Where do you think cosine is at 1/2 at? Okay, or you can do it this way. There are multiple ways of solving a math equation. So don't feel the need to follow my way if you already know how to do it. So for next is I'm going to compose both sides by cosine inverse. So now we have 2 theta is cosine inverse of 1/2. Okay. Now, there's a couple of things I'm going to remind you. This is a normal function, okay? Normal trig. No restriction. No restriction. So keep that in mind. Even though we're borrowing inverse to solve, even with using inverse to solve, okay, there's no restriction whatsoever. I want you to keep this in mind, okay, because this is a regular cosine. You always want to look at the original equation, not what you are using or not what you are borrowing in the process of solving, okay? So because the original equation is a regular cosine, there's no restriction whatsoever. So cosine inverse of a -1/2 is at 2 places. Here, because it's positive. I'm sorry, cosine inverse of the +1/2 is at 2 places, here and here. Okay, so I'm going to be looking at, hey, you know what? This should be a pi over 3. And this should be a 5 pi over 3. Okay, so I'm going to have 2 different angles for this one. Okay, keep in mind, we're starting with a regular trig function. We have no restrictions whatsoever, okay? So we will write 2 theta equals pi over 3, or, and then we have to solve it, okay? 2 theta equals 5 pi over 3. But you're not solving for 2 theta. Solve means just solving for 1x or 1 theta. So what you need to do is we're now going to multiply both sides by 1/2 to get rid of the 2. So theta is simply pi over 6. And over here, similarly, we're now going to multiply this by 1/2. So now theta is 5 pi over 6, okay? But keep in mind that you're writing this equation, okay, writing the answer for theta from 0 to 2 pi. So guess what? The period's coming back, okay? Find the period of this equation. So period is 2 pi divided by absolute value of b. Absolute value of b is 2, so this period is a pi. So why do I need to know the period? The period matters because it repeats, right? Every single period, it repeats itself. So I need to go and add a period, okay? Or sometimes subtract a period to see if it's still within the restricted angle that they want. So if I add up a pi, okay, which is a period, would I still have, so pi is going to be 6 pi over 6. Okay, this is now 7 pi over 6. So that's one answer. This is answer number 2. And this one, theta equals 5 pi over 6. A period is 6 pi over 6, which is a pi. So now this is 11 pi over 6. Okay. So with denominator, so this is the first answer, this is second answer. With the denominator of 6, 2 pi equates to 12 pi over 6. So I don't think I can add any more, because a period with the denominator of 6 is really 6 pi over 6, okay? So if I add 6 pi over 6 to this, then it's over 12, okay? Or if I subtract 6 pi over 6 to that, then it's negative, which is not at all part of the restriction that they wanted. Exactly the same thing, right? If I add 6 pi over 6, it's 13, so that's more. If I subtract, then it's negative. So that's why these are the only 4 answers that you can have. Pi over 6, let's put it from smallest to biggest. And last one. Okay, so when you see restrictions like this, that means you're listing out an answer, okay? All right, let's go to B. Again, B starts with a regular tangent, so keep in mind that it has no restriction. It can be anywhere it wants to be. So let's solve it normally, okay? So radical 3 times tangent of 3 theta equals -1. Divide both sides by radical 3. So we have tangent of 3 theta equals -1 over rad 3. Because this is a normal tangent, okay, I can have in quad, let's see, tangent negative in quad 2 or quad 4, okay? So the question is, what angle is going to give me answer of -1 over rad? By the way, if you remember, -1 rad 3 is like negative rad 3 over 3, okay? So what should I use? What is this angle? Did you say 5 pi over 6? Okay. How about this one? What is this angle? Wow. Did you say 11 pi over 6? Okay, then those are the ones we're going to use, okay? Or you can even think of it as, hey, 3 theta equals tangent inverse of a -1 over rad 3, which means 3 theta equals 5 pi over 6, or 3 theta equals 11 pi over 6. Okay, now why can't I use negative pi over 6? I don't want to, because you're restricted. The restriction for theta is positive 0 to 2 pi, okay? So let me erase because I feel like I'm... Okay, so let's keep on going. So am I solving for 3 theta? No, I'm not. I'm solving for 1 theta. So what I'm going to do is I'm going to multiply this by 1/3, okay? So now 1 theta is 5 pi over 18, okay? Same thing with this. Multiply this by 1/3. So 1 theta is 11 pi over 18. Okay, so let me ask you, are those the only 2 answers that can be from here to here? Okay, are those the only 2 answers that can be from here to here? No, they're not, right? Because you have to find the period, okay? Look at this. This right here tells me there's a horizontal compression factor of 1/3. So the period is pi divided by b. So the period is pi over 3, okay? With denominator of 18, because as you can see, I'm going to need to add a period soon. That means this is 6 pi over 18. So that's what it means to have a period, okay? It's not asking for a period, but you need to know. Because what you need to do is you're going to need to add or subtract a period, which is pi over 3. Add or subtract a period, which is pi over 3. Okay, so what happens when you add a pi over 3, which is aka 16 pi over 18, okay? So this is really 5 pi over 18 plus 6 pi over 18. Your next angle is going to be 11 pi over 18. Oh my gosh, that is exactly the same as this. You are right, okay? The thing about tangent, is that notice how it's directly diagonal from one another. It's okay, okay? So what you did now is you're going to keep on adding 6 pi over 18, a period, 6 pi over 18, until you get to 36 over 18. And why am I mentioning 36 over 18? Because 36 divided by 2 is, 36 divided by 18 is 2 pi, so that's when we need to stop. So I'm just going to keep on adding, add 6 pi over 18, okay? So now I'm going to have, what, 23 over 18 now? Okay, and then add 6 pi over 18. No, need to box that up. I'm boxing all of the ones that I need to. Keep. Okay, so that's what, 29 pi over 18. Okay, and then plus 6 pi over 18. So that's going to give me what? 35 pi over 18. Okay, I think this is where I'm going to stop because the next one is 36 and I can't even have 36. So all of my answers are from smallest to biggest. 5 pi over 18, 11 pi over 18. I'm not going to write both of them out, obviously, because they're exactly the same. So just write it once. And then 17 pi over 18. Then 23 pi over 18. Then 29 pi over 18. Then 35 pi over 18. So if you notice, there's an increment of 6 pi over 18, which is a period. Okay? Now let's go on to our next one. C. It looks slightly more difficult, but is it really? Okay, so let's check it out. So you have a phase shift right by pi over 4. Okay, so what I'm going to do is theta minus pi over 4 equals cosine inverse of 1. Keep in mind, this is a normal, okay, this is a normal cosine, so there's no restriction, okay, but that doesn't really matter anyway because cosine can only be 1 at 0 or 2 pi, okay. So let's see. So theta minus pi over 4 equals, but if you think about it, 2 pi is not included in my theta restriction, so I can't even use 2 pi, so it can be 0. Okay, so I'm just going to solve for 1 theta, so I'm going to add pi over 4 to both sides, so now theta equals pi over 4. And I believe that's the only answer I can have, but we can check the period to see if anything's special on the period. The period is just 1, so it's just going to be 2 pi over 1, which is 2 pi. So if I add 2 pi to pi over 4, it's just too big. It's beyond the restriction, so I can't have it. Okay. Example D. Oh my goodness, 2 cosine square of theta minus cosine of theta minus 1 equals to 0. How am I supposed to solve this? Okay, easy. Let cosine of theta be u. So now this is just u squared with 2 in the front of it minus u minus 1 equals to 0. Well, let me give you a hint. You can totally factor this. Factor like algebra 1, okay? So the factors are u and 2u, okay? So what do I need to do? Where do I put the ones? So let's see. Can I put a 1 and 1 here? So let's distribute out the negative and positive to see where it goes. We can try positive here, negative here, and let's check, okay, to see if we get what we get. U times 2u is 2u squared. U times negative 1 is negative u. This is going to give me 2u and minus 1. When I add these, it's going to give me a positive u. So currently my signs are wrong. Okay, so that's not going to work. So what I will do now is I'm going to erase my sign and switch them. So now this is a plus and this is a minus. Okay. All right, let's check it again. Round 2, check. U times 2u is 2u squared. U times negative 1 is positive u. Negative 1 times 2u is negative 2u. And negative 1, so when I combine that, it's going to give me negative u. Yay, I did it. Okay, so now that we got our u's, we are going to say, take each factor and set it equal to u. You're just doing exactly what you did in Algebra 1. There's no difference here then except we have sine and cosine and tangent and so on, okay? So now u equals to 1. And over here, let's solve 2u equals negative 1, u equals a negative half, okay? Well, we kind of let u be something. So what you need to do is take this and plug it back in here, and take that and plug it back in there, okay? So what is u? U is cosine. So cosine of theta is 1, and cosine of theta is negative 1/2, okay? So from here, cosine of theta is 1, it's only at one spot. It's right there. So theta has to be 0, okay? 0 radians, 0. Sorry, I had to text my mom. My kids are sick. All right, how about cosine of theta is negative 1/2. Negative 1/2 is going to be in quad 2 and quad 3 for cosine, okay? So these two angles. So what angle is this? This has to be what? What is the angles? So that way I can still have negative 1/2. Did you get it? I'll give you a couple of seconds, a couple more seconds to think. Did you say 2 pi over 3? Okay, I'll take it. How about this one? Did you say 4 pi over 3? Sounds like a great idea. Okay, so the two angles for cosine is going to be 2 pi over 3 and 4 pi over 3, okay? So now we will just put them all together from smallest to biggest. So theta can be at 0. Oops, I meant to write 0. Theta can be at 0 radians, 2 pi over 3 radians, and 4 pi over 3 radians, and can still make that equation true. All right, so it's about 19 minutes. This is where we will stop. We will continue with the rest of them next time or in class. Have a wonderful night. So here we go. Let's see, what can I think of? Why do bananas have to put on sunscreen before they go to the beach? So why do bananas put on sunscreen before they go to the beach? Because they might peel. Get it? Haha, banana peel. All right. Hopefully you enjoy that toddler joke. So we are solving, so keep in mind that this is a regular. So if you look at, check if this is regular trig function. So technically there is no restriction, but remind ourselves of where they want our answer to be. So they wanted our answer for theta to be from 0 to 2 pi, inclusive at 0. So inclusive at 0, but not inclusive at 2 pi. Okay, so the best thing to do is to see if we can change anything. Okay, we have sine square here, a regular sine here, and a cosine. So in one equation, that's a lot of different trig functions. So what you want to do is, hey, can I change one of the trig functions into common trig functions? So for example, cosine square seems to be a little bit odd in this equation. So the first thing I'm going to remind you of is this Pythagorean theorem for trig. Cosine square of theta plus sine square of theta equals 1. Super important that you know this. Okay, we learned that already, but we haven't used it, so hopefully this is coming back. And I want to get rid of cosine square and change it to sine square of something, so I can combine like terms. So I'm going to solve for cosine square. So cosine square theta equals 1 minus sine square of theta. Okay, so every time I see a cosine square, I can take it out and put this in there. So here we go. Let's rewrite our equation. Sine square of theta minus sine of theta equals, I'm going to take out cosine square and put this in. So that's going to be 1 minus sine square of theta. Then I'm just going to put everything on one side. So are you ready? So the next thing I'm going to do is add sine square to both sides. Okay, so those are now canceling. On the left side, I now have 2 sine square of theta minus sine of theta. On the right side, I still have 1. So the next task I'm going to do now is subtract 1 from both sides. So now I have 0 over here. On the left, 2 sine square of theta minus sine of theta equals -1. So now let's check this out. We are here, we're trying to solve for theta. Okay, very similar to this, don't you agree? Guess what you're going to do next? You can factor it out, okay, using u. And by the way, you don't have to use u, okay? Let u be sine of theta. So you can write 2u squared minus u. Oops, this should have been a -1. My bad. -1 equals 0. Okay, do me a favor and factor it out. I'll wait for your factors and I'll come back. Okay, take a minute. However you factor. Once you have the factors, write it in. Don't forget to check your factors to make sure the factors are, when you multiply them back, they get the original. Did you come up with the factors? I hope you did. Okay, so did you end up with 2u plus 1 and u minus 1? Okay, if you doubt your factors, just quickly check it. Okay, 2u times u is 2u squared. 2u times -1 is -2u. In the middle is positive u and -1. When you add that, it should be equal to this. So we are okay. Then take each factor and set it equal to 0. So 2u plus 1 equal to 0. U minus 1 equal to 0. Then solve for u. Okay, so 2u equals -1. U equals -1 over 2. Similarly, u equals to 1. Okay, but obviously we're not trying to solve for u, we're trying to solve for theta. So put it back. U is Whoop, put it back. Whoop. Okay, so we now have sine of theta equals negative 1/2, okay, or sine of theta equals 1. Sine is 1 is only at one location, okay, it's at pi over 2. So this one, I only have one answer. Now sine of negative 1/2, you're going to have two locations, here and here. So can you tell me the angles for those? Okay, did you say that it would be 5 pi over 6? I'm sorry, not 5, 7 pi over 6? Good. How about the other one? Did you say that is going to be 11 pi over 6? Great, okay. And that's all I needed, and let's just write it from smallest to biggest, okay. So theta is going to come out to be pi over 2. 7 pi over 6, and 11 pi over 6. Okay. Now think about this. 11 pi over 6 is already near 2 pi, so I don't have to worry about the period. So anytime that you have to factor, you don't have to worry about the period. Okay. Last problem. I'm going to use a different color just to separate my two questions here because it seems like I invaded F. Okay. This one, you can do this in a few different ways. Notice how you have sine square and cosine square in one equation. You can totally substitute, okay? Get rid of cosine square, just like what we did here. So here we go. 3 sine square of theta equals, every time I see cosine square of theta, I can replace it with 1 minus sine square of theta. And of course you can substitute sine square of theta as well, okay? So if you were to write sine square of theta, it should be 1 minus cosine square of theta. You can substitute whichever one you pick as long as it makes it easier for you to solve, not more difficult, okay? So from here, just like earlier, I'm going to combine like terms. So this is 4 sine square of theta equals 1. Divide both sides by 4. Sine square of theta equals 1/4. Take the square root. So now I have sine of theta equals plus or minus 1 over 2. Okay, what does this mean? This means that I have sine of theta equals positive 1/2 or sine of theta equals negative 1/2. Well, sine is positive here and here, so that's two answers. And cosine is sine is negative here and here. That's another 2 answer. So can you do me a favor and find all of those answers? What are all those angles? Did you say multiples of pi over 6? Then that is correct, okay? So we will have all of these answers together. So let's write them in. Theta is smallest to biggest. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And that is my box answer. Now, is that the only way to go about this? No, not really. I can also go this route, right? Here's your original question. 3 sine square equals cosine square of theta. What if I don't feel like converting cosine into sine or sine to cosine? Then I can do this way. Divide both sides by sine square of theta. Then I have 3 equals to cosine square divided by sine square is going to be cotangent square of theta. Okay. Then I'm going to take a square root. So now I have cotangent of theta equals plus or minus radical 3. Then again, because it's positive and negative, I again will have 4 answers, right? Cotangent is positive radical 3 in quad 1 and quad 3. And cotangent is negative in quad 2 and quad 4. And the angles are still the same. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So it doesn't matter how you solve in mathematics. If you do it right, then the answer will always be the same. This is the end of our notes. Example 2. Solve each. Round to 2 decimal places, and theta is in between 0 inclusive to 2 pi non-inclusive. Then use the calculator to check your solutions. So what this means is when it says round, that means we are able to use your calculator. For letter A, there are actually 2 different ways you can go about that. Now letter B, there's only right now one way for us. So letter A says cosine of theta equals 0.2. That's a positive ratio. And so positive cosine, it's a regular function. There's no inverse here, so mind you. And so that means cosine regular, it's positive in quad 1 and quad 4, since we have to go a full revolution. A full revolution means you start at 0 and then you end back at 0. So we're going to compose both sides by cosine inverse. That will lead us to 0.2. I'm going to find my decimals and type that in. So give me 1 nanosecond here, decimals. As we are loading, I'm going to find my function. Let me double check to see if in radians. Okay, I am. So cosine inverse of 0.2. That gave us 1.37. So let's go back to the notes, type in theta equals 1.37. But that's not all, because we know that we need another answering quad number 4. So here's a reference of 1.37. That means this reference on the bottom is also 1.37. But we're not going clockwise, okay? Because clockwise will indicate we are getting a negative radians of 1.37. But your restriction said it's a positive angle only. So we are going to go from here all the way to here. So what that means is we are going to take 2 pi, which is a full revolution, less the 1.37 radians. So let's go take my decimals again and do 2. Let's see if I can find the pi. 2 pi minus 1.37. That's going to give us 4.91. So go back, record that, 4.91. So you guys have 2 angles in radians. Theta is 1.37, comma, 4.91. Box that up. Now, earlier I said you have 2 different ways of finding the solution I meant for example 2a. Another way is we can graph this out. Okay. To graph this out, let's go back and look at the equation quickly again. As you can see, you have cosine of theta equals to a constant value, and it doesn't have to be constant. So we're going to break this up into 2 equations. The first equation is going to be cosine of theta, which is in decimals. I think you can use x. And the second equation is going to be y equals 0.2 and where they intersect. Remember, back in the days, to find an answer is to find where the 2 functions intersect. So y equals function cosine of a variable, which is that one. And I'm going to change it to from 0 to 2 pi soon. Then next, we're going to do it again. Y equals 0.2. Now over here, I'm going to take the wrench and my x-axis, I want to change that. Let me just move my computer back here. We want it from 0 to 2 pi. So this goes from 0 to 2 pi. Okay, and there you go. And we can even see that we can even label each step as a pi over 2 or pi over 4. Let's do a pi over 2. There you go. That will allow us to see a little bit here where they intersect. As you can see, they intersect at 2 places, which I will be able to spot out here. The first one, let me make it a little bit darker. Projector mode. There you go. So that allows me to see the first point of intersection, which is this dot. Okay, so that's going to be 1.37, which we knew at the height of 2. Then the second intersection is all the way over here, past 3 pi over 2. Hopefully, okay, so make sure the y value is 0.2. There you go. So 4.914, which by 2 decimal places is 4.9. Well, make sure my height again is back at
4.2. There you go, 4.91. So as you can see, we get the same exact two solutions by graphing.
Now example B. Example B, you cannot just go and use a calculator and do like this step right here on example A, like example A. So we actually have to graph it out. So similarly to graphing example 2A, we're going to do the first y equals. You pick a side, okay? It doesn't really matter what the first y is. Whatever side you pick, that's okay. And the second y is going to be 4. Now, some of you said, well, can I move the x to the other side and just do the first y equals 3 cosine of x? Sure. And then the second y equals 4 minus x. Yeah, either one is totally fine. So you don't have to worry about how you write in y equals, as long as one side of the equation, it's on one of the y's, and then this, or on one of the equation box, and then the second on the other side is the second equation. So let's go and do the 2. Okay, so y equals 3 cosine of x plus x. I'm going to delete what we had earlier, so I don't need to worry about extra graphs. So y equals function cosine of x, make sure I close that and go outside, minus, oh, I don't need a function, minus x. Yes, you don't see anything right now because it's hidden below me. And then as you can see, oh, 3 cosine of x plus x. I lied. 3 cosine. What? 3. Okay. And then the second equation is y equals 4. So y equals 4. Y equals 4. Let's find the graphs and see where they intersect. Remember earlier we already restricted it from 0 to 2 pi. Okay, so here's what I got going on here. Let's look back again. So 3 cosine of x plus x is one equation. Let's double check, and y equals 4. I want to make sure I enter those in correctly. Go back out. Okay, oh, plus x, duh, look at that. So I did a minus and they don't seem to intersect. Let's see if that's, okay, so now I entered the equations incorrectly. Oh, wonderful. So from 0 to 2 pi, remember that's a restriction. There's only one location that they intersect. So that's going to be 4.53. Let's go back, fill that in. So theta equals 4.53. Now what happens if I enter this in right here? Do you think we're going to get the same answer? Let's try it out, right? So y equals 3 cosine of x, and the second y, I'm going to do 4 minus x. So the first one, I'm going to delete the plus x. And then we said, okay, well, move the x here, no big deal. Okay, now let's look at it again to see where they intersect. The graphs are slightly different, and that's supposed to be because we modified the equation, but the answer should be the same still. Okay, so let's see this x location. 4.53, look at that. The y values are different, right? And it doesn't really matter. We're solving for the input, which is your x. So it doesn't matter how you move your equation, you should always get the same answer.